Hello everyone, I am Dipal Patel. In previous video, we learned about working standard, internal standard, reference standard and how to prepare calibration curve and quality control sample. Now today we learn about parameter for method validation and experiment like carryover, selectivity, specificity. Parameters for method validations like selectivity, specificity, accuracy, precision, limit of detection, ruggedness and robustness, matrix effect, repeatability, reproducibility, linearity, recovery, stability, instability like freeze and throw stability, benchtop stability, blur stability, stock and working solution stability, auto sampler stability, dry extractor sample stability, long term stability and process sample stability. So this all are experiment we perform during method validation. Now today we learn about selectivity, specificity and carryover experiment in details. Later on we will learn another experiment on next session. Now we learn about selectivity. What is selectivity? Selectivity is the extent to which the method can determine an analyte of interest and internal standard in the matrix without any interference from the matrix component. Now, what is purpose of selectivity? First, to prove that our method can selectively determine our analyte of interest and IS only. Second, to prove that our method is selective even if we used different plasma lots. As you know that in B study, number of subjects take parts. So, each of these subject plasma samples have different characteristics. So, selectivity experiment is performed to prove that our method is selective even if we use different plasma lots. Now, I will explain how to conduct selectivity experiment. Take 6 different lots from different person. We call normal plasma lots, one hemolyzed and one lipemic plasma lots, and prepare LLOQ from each plasma lots. Why we take hemolyzed and lipemic plasma lot? As we know during study, we have some sample for hemolyzed and some of lipemics. That's why we take hemolyzed and lipemic plasma lot to prove selectivity also. Now we is looking for acceptance criteria. We check area in all blank samples. Here at RT means retention time of analyte less than 20% of area of LLOQ, and at RT means retention time of internal standard less than 5% of area of LLOQ. Now I will explain how to check acceptance criteria by example. Now we know that we take 6 different lots normal plasma, one hemolyzed and one lipemic. Okay, but I will explain here one of lot by example. For example, from lot B1 we prepare one blank sample, and from lot B1 we prepare LLOQ sample. Then we inject this both sample in LC-MS instrument, and then we get area of blank sample 10 and LLOQ area is 1000. Now, as per acceptance criteria, area in blank samples at retention time of analyte should be less than 20% of area of LLOQ. Now, we have area of LLOQ is 1000, and if we calculate 20% of 1000, then we get 200 area. Here, blank sample area is 10. That means it is less than 20%. So, here this lot is pass. Now, we have another example. We prepare blank and LLOQ from lot B2. Then we inject blank sample and LLOQ sample in LC-MS instrument. Then we get area of blank sample is 250 and LLOQ sample area is 1100. Now, if we calculate 20% of LLOQ area, that means we have 100 1000 area in LLOQ. Sorry, 1100. If we calculate 20% of 1100, we get 220. Now here in blank area is 250, which is more than 20%. So as per acceptance criteria, this lot fell. In the same way we calculate for another lots and for IS also. But here we can calculate for IS just 5% instead of 20%. Now we learn about specificity. Now, specificity is ability of the method to assess unequivocally the analyte of interest in presence of other components like impurities, matrix component and co-medication. Now, what is purpose? To prove that our method is specific to identify analyte of interest in presence of another plasma components or co-medications without any interference. Co-medication means commonly used medications such as paracetamol, ibuprofen, chlorpheniramine as well as nicotine and caffeine. Now we know that in plasma samples there are several other components like protein metabolites of drug as well as some drugs such as paracetamol, ibuprofen, chlorpheniramine malate, and if subject is a smoker then have nicotine in plasma. And of course, subject is drinking coffee, so have traces of caffeine in plasma. So purpose of specificity experiment is to prove that our method can very specifically identify an analyte of interest even in presence of another components. Now how to conduct specificity experiment. Spiked blank plasma lots, 6 normal, 1 hemolyzed and 1 lipemic with Cmax of co-medications. Prepare LLOQ sample in each plasma lots. Prepare 6 low QC sample and spiked with Cmax level of co-medications. Now I will explain by this example. For example, here we take B1 plasma lot. Here we spiked Cmax level of paracetamol, Cmax level of ibuprofen and Cmax level of chlorpheniramine malate in blank plasma. Here we not add any analyte. Here we spiked just LLOQ of analyte. Now we prepare low QC samples spiked with analyte at low QC level, Cmax of paracetamol, Cmax of ibuprofen and Cmax of chlorpheniramine malate. So here we prepare blank sample like this, LLOQ sample like this and low QC sample like this procedure, and we repeat this all sample for another lot as well and then inject in the LC-MS. We see acceptance criteria. First, area in all blank sample at retention time of analyte less than 20% of area of LLOQ and at retention of I internal standard less than 5% of area of LLOQ. And we say accuracy of low QC samples should be within plus minus 50% of nominal sample value. Now we can see this all criteria like this example which I explained in the selectivity. Here for low QC sample, for example, we have concentration for low QC is 100 nanogram, then it's within 85 to 115 concentration. Now we will see about carryover experiment. What is carryover? Carryover is the appearance of an analyte signal in blank sample after the analysis of samples with high analyte concentration. Now, what is source and reason of carryover? First, inappropriate sample dilution or diluent, inappropriate mobile phase, inappropriate washing duration. Sometimes we inject blank sample after high QC and we get area. in the blank sample. This is called carryover, and this is the source and reason for that carryover. Now, how to solve this carryover? First, extend washing duration. Second, change mobile phase or diluent. Now, how to conduct this experiment? Inject blank extractor sample after high QC or ULOQ samples. As per our in-house practice, we inject blank sample in all accuracy and precision batches. Now, acceptance criteria for carryover. Area in blank samples at retention time of analyte less than 20% of area of LLOQ, and at retention time of IS less than 5% of area of LLOQ. Here also we can calculate like this example which I explain in the selectivity. So this is all about carryover experiment, selectivity and specificity experiment. Thank you everyone. In the next video we will learn about another experiment.